No. The bad thing about his introduction is it silenced me. Too much compliments. Okay, thank you very much. Very nice introduction. But do not believe everything. Judge me based on what I present. Computational social epistemology, two armed bandits, strange types of truth seekers. Oh, have to get used to this.
Crusty.
Yeah, let me look there now. Yeah. Let me describe the key components of what I will present. So it is agent-based modeling, but it is agent-based modeling with regard to a special stylized situation. We have social exchange between agents, for the most part, here at the moment imagine scientifically interested agents, and they get signals from the outer world. That is my stylized scenario. Okay, we have to speak about how to model social exchange, and then we will look at agents that process worldly evidence. Carnap's inductive logic will play a certain role, but basically it is only one way to look at inductive logic or inductive learning, as bounded confidence, which is my reference, is only just one model. That is the basic structure, and then of course computation. A lot of persons are here in the room that know bounded confidence. Therefore, I will be very short about the details. As I said, bounded confidence has no monopoly. There are lots of other models. I mentioned three, all of them based upon continuous opinions, but we have lots of other models which assume binary opinions or certain numbers of different opinions. The one you could think of similar to bounded confidence is the famous and first de Groot model. Then there is an extension, Friedkin-Johnson, in which again, weighted averaging is a point, but there is some stubbornness in each agent sticking to the original opinions. And then we have this bounded confidence model in which you can't assign weights to others because you do not know their identity. The only thing that you have is their opinions. And the idea of bounded confidence is you take seriously the ones that are not too far away. We start with one-dimensional opinion dynamics. We have a set of agents, we have a discrete time, we have a start profile, and what bounded confidence then does, different to the weighted averaging of the models to the left, is simply important is the set of epsilon insiders. That are the ones that are not further than epsilon to the left, epsilon to the right of your present opinion. That is this set. And then updating is only summing up of all opinions in your that are epsilon insider opinions and divide by their number. That is the primitive mechanism of bounded confidence, and that is my starting point for social exchange. Here you see three examples. They have always the same start distribution, about 50 individuals, and they simply differ in the size of this damned epsilon, the bounds of confidence. And what you see, very small epsilon, we have the opinion space between unit interval, is it? Very small epsilon, we get in finite time a certain number of clusters, epsilon increases, and now we have polarization, as we could call it, just two clusters. If epsilon increases even more, we get, after some time, not very much, we get a consensus. That is how it is in this model. Let's try to understand how comes. That is not that difficult. Here, an example with equidistant placed start opinions. Additionally to the color trajectories, you see vertical lines here. What do they do? And indicate. Between two neighboring opinions, I draw a gray vertical line if and only if the distance between the two opinions is not greater than epsilon. So they have an impact on each other. Looking through the dynamics, what do we see? Well, condensation of opinions at the outer borders, here and there. The condensed areas attract opinions from the center. Suddenly here, we do no longer see vertical lines. And that means the network mutual impact has fallen apart. There is no longer any influence from the lower segment of the profile on the upper and vice versa. So what we are observing is, and that have in mind, it was defined in terms of a dynamical system. To understand the network perspective, dynamical network perspective is much more important. And we see it has fallen apart in Unit 4. And now we have two subcommunities which do not have any connection and impact on each other any longer. So the basic mechanisms, keywords are shrinking and condensing from the extremes, split, collapse into just one opinion, and finally, finite time that was proven already in our original paper in 2002, stability. That is what we get. If you play around a bit with this model, you get immediately, I mean, the idea is, let's increase the epsilon and look what happens. And then you get pictures like that, increasing values of epsilon for small ones, plurality, then polarization, then consensus. And the extremely suggestive intuition is, well, yes, phase transition, simple type, plurality, polarization, consensus. That is the immediate intuition you get. As epsilon increases, the final profile width should go down, and the numbers of clusters should go down as well. That are the intuitions. The problem is they are completely wrong. I believe that, by the way, for probably 15 years, working on that model, and only then realized completely wrong in a certain way. Here you can see what in fact is the case. That what you see are no longer trajectories. That are the endpoints, the fixed point, the stabilized final positions of clusters for different, and they are increasing values of epsilon. So that is what I call a switch diagram. Why switch diagram? At the beginning, Ulrich Krause and me, we developed that model together during long distance running in the Bürger Park of Bremen University, starting in the middle of the 90s. He had originally the idea to analyze such dynamics, but being a traditional paper and pencil mathematician, he could not manage more than 4 or 5 opinions, tortured me during our run. In the end, I said, well, it can be solved computationally easy, no? Not a difficult task. Then we started, or I started then increasing epsilon values. Okay, and then let's look what happens. But think it through. Only a certain number of epsilon values really make a difference. Not all epsilon values make a difference. Think of a certain start distribution and think of an epsilon of 0. What will happen? Simply nothing. When will epsilon, when do we get to an epsilon that matters in terms of changes the dynamics? If we increase epsilon a tiny bit, nothing will happen. But once we get to the nearest epsilon outsider, an epsilon with a distance that equals the distance to the nearest epsilon outsider, in that moment, for the first time, increasing epsilon, something new happens because there is a certain impact. And that we simply continue. We simply continue that idea via an algorithm, and thereby we will find all epsilon values that matter in terms of they change the network structure, thereby they change the trajectories, and the result for a start distribution, that was equally spaced of 18 agents. The result of that you see. It is a finite number of switches, epsilon values that matter. You do not see all. Wherever you see these light gray vertical lines, that are the epsilon values that matter, given my algorithm. The colors or the circles indicate the positions of the final stabilized clusters. Their color indicates their size. And have in mind, it is gray circles that are clusters, that are consensus clusters. Only the gray circles indicate that. Okay, if we look at that, the graphics shows triangles. Here, black, red, and on top you see as well smaller triangles. All these triangles indicate non-monotonicities. Let's start with the triangles on top. Wherever there is a vertically directed triangle, that means the width of the profile compared to the switch before is increasing. It is increasing. Against our intuition, it would decrease. Here, you see triangles on the x-axis that indicates the number of cluster is increasing. And especially interesting are here the red ones. That indicates increasing in a specific way. A consensus is falling apart. And we get, under a bigger epsilon, polarization again. And it is a polarization, a consensus turns into a polarization of two clusters. You do not see orange triangles that would indicate 3 clusters. So what we see is, by the triangles, non-monotonicities. Okay, the obvious questions immediately is, how comes? That can be easily explained. It is an example with 42 equally spaced opinions for the start, and that is our initial period, or our situation from which we start with. And we look at that opinion under the given switch, it is that value, we see how this opinion here moves upward. If we look at the next switch, the follow-up switch that we have, this is the trajectory for that dynamics. That is the same opinion, but different from here. Under the bigger epsilon that we use here, this opinion pulled upwards here is not pulled upwards completely in the next switch. It forms a bridge between the center and the outer cluster, same as here. But under the next switch, that is what we had before, under the next switch, a bigger epsilon, that opinion that here functions as a bridge is pulled upward. The bridge is destroyed, and we get a clustering, again, now with a non-empty center, but major clusters out there, out here, and a certain center cluster. The point here is we have to look under the network perspective and destroy bridges between center and outer clusters. That is, so to speak, the obvious secret behind this monotonicity that we observed. Okay, so that is the wrong intuition. The complete story, I make it short, is finally, of course, there will be a consensus. If epsilon is 1, given a start profile and my opinion space, of course, consensus already in the period 1, if we start with 0, that is clear. But in between, it is finally there will be consensus. Just one cluster and a 0 profile width, but the transition is wild, chaotic, and non-monotonic. There's a bad news or a bad technical note. This simple algorithm does not work with floating point arithmetic. You need exact mathematics, exact computation, and that means fractional arithmetic consistently, and you need integers of arbitrary length. That is behind that. I could speak about that later if you are interested in that, but maybe it is better you look into this article in which all the technical problems to detect the relevant epsilon values, they are described in detail. There you see that. We had overlooked that in our article. I mean, we didn't write that it is a monotonic process, but I remember fairly well why we didn't write that in our original article. We didn't write that because we consider it trivially true. That was the reason why we didn't write that. That was not insight. Why was this bounded confidence revisited article written by me alone? That has a certain background. Ulrich Krause, he is 10 years older than me. We are till today close friends. We discuss that on a regular basis, but we couldn't agree upon our approach to that problem or that article. To make it short, Ulrich because what I'm doing is to have an algorithm, and with that algorithm, I detect all switches the epsilon values that matter, and then I analyze all epsilon values that matter under the perspective whether they constitute a monotonicity or not under this or that perspective. He thinks the only switches that are really interesting from a theoretical point of view are the ones that destroy a consensus. And he said that is already in the start profile, somehow inherent in that. I agree. But he thinks he is able to find out, given a start profile, directly, somehow using paper pencil analytical methods to identify in advance whether or not that has this type of non-monotonicity. As to that, I think it does not work. He did not succeed so far. He had promised that by the time the articles had to be delivered, he would have a solution. He did not have a solution and refused to be co-author on what I have written. He still hasn't a solution for that. My personal impression is that is a computationally irreducible problem. You have to do the complete computation the way I did it, and then you filter out after that what are the monotonicities that he is interested in. Okay, that is the background, but now truth-seeking. Bounded confidence that is simply averaging. There is no truth, no external signal from the world. How can we incorporate that? Okay, we had an idea already in the past and published in 2006 a paper in YAS again. And what we did there was simply, let's assume there is a truth. Somewhere in the opinion space, a capital T, the truth, and that capital T has an effect. We did not try to go into any details. We simply assumed there are people that have a certain sensitivity to the truth, and instead of being affected only by social exchange, they are also affected by this signal capital T. And we have simply a convex combination, alpha I times capital T plus, and now the social component. The old bounded confidence social component comes. That is what we have done in this article in 2006. That approach I want to give up. What I want to do is, in this convex combination, the capital T, we substitute that by an inductive learning process. You could think of a Bernoulli process, repeated coin flipping, unknown bias of the coin, and people try to learn. So agents run experiments, observe, and learn inductively. That is what I will do now. And I want to do that in a certain context, and that is the multi-armed bandit problems context. Bandit problems, what is that? Okay, we have a certain stylized scenario with a sexy name, as Prisoner's Dilemma is a sexy name for a certain problematic social structure. Same here. What we have is slot machines, one-armed bandits, different payoffs, unknown probabilities. What to do? what to do and how to play. If we describe this situation a bit more precisely, so over a number of rounds, again and again, you have to choose between arms. Unknown but fixed success probabilities that lead to a certain reward. What to do? Over the time you learn, you do some exploration, but you have to put money into the machine. You have to put money into the machine, so learning is costly. Learning is costly. And therefore you have to somehow to balance between exploitation of you have already found out, exploration. Various instances, it could be the problem which medical treatment to use. So life, years, death may matter. We are speaking about, could be speaking about medical policies, and other examples might be that's all. That is already from 1933. That is easy to read, very accessible, well-written introduction to this kind of problems. Okay, inductive learning now. I want to focus on a two-dimensional bandit problem. So we have two arms, two policies, two treatments. The true probability, the objective probability, that is the green dot, you see a random start distribution. And we have to apply now inductive learning on that. There are lots of ways to do that. I here use inductive logic of Carnap as it is described in his early book 1952, The Continuum of Inductive Methods. And what you have there.
They say that the audio is quite low, so maybe
It's off.
It's off. Yeah.
Okay. What we have in Carnap's inductive logic is we have a set of elementary outcomes, and we have a certain experience or results of experiments in the past, and then we update given our experience from the past. The details do not matter very much. And we have a guess for the probability of a certain event, success of a certain arm, based upon what our experience was in the past, where a certain lambda plays an important role in Carnap's conception, and that is somehow the weight that you assign to your past experience compared to your recent experience. The details do not matter very much for what I'm presenting, but we can discuss details later of that. I only make the remark, there is a certain equivalence between certain lambda values in terms of Carnap and Bayesian updating that is discussed for the favorite conception today. But we could substitute this inductive learning method by any of the mechanisms that are discussed and get the same framework. Okay, now bounded confidence and connecting that with this inductive learning. okay, the basic idea is we substitute the old attraction of the truth, social component, objective component, we substitute that capital T by Carnap's learning mechanism. That is what we do. And then we get for arm A this type of updating. Again, we look in a certain distance, opinions in a certain distance, take that, and then we do our averaging, but we have a convex combination. And we would do that correspondingly for the second arm. But what is the distance now? Two-dimensional space, we could define the distance in different ways. For instance, that the sum of distances should not be greater than epsilon, or that no distance should be greater than epsilon. I simply use Euclidean distance. That is the focal agent, and whoever with his or her opinion is within that distance is taken seriously. And that is then used in this or the corresponding updating rule for the other. That is my framework. And now let's do the first step. So let's assume we have lonely Carnapians. Left lonely, no exchange with us. What will then happen? We assume that the truth seekers play the arm that they actually consider the better arm. That immediately means that the diagonal here is a watershed. If you are above, you play the arm A, below you play arm B. Let's look what will happen. You see what is going on. Forget about the statistics part, that comes later. That is what we see. And what do we see? They seem to get to close to one of the right probabilities, but just to one. And that has a certain reason. Or no, to that in the next step. That was before lonely Carnapians. They spread a bit around the true values of one of the arms. Now let's have some social exchange. And what we get then is, okay, they get clustered. They get clustered. Additionally, be aware, I have drawn a gray zone along the diagonal. And given that the truth seekers choose the arm that they consider best at the moment, it is only in this gray zone, size of epsilon, in which agents that actually play different arms can meet. Only there is an exchange between agents that play different arms. That we have to have in mind. What we realize here immediately is that is not a good policy, not a good epistemic policy. Truth seekers, if they play the arm that they actually consider the better one, they will get close to the true probability of one of the arms, but that may be the worst arm. So more exploration is necessary to get to reasonable results that is immediately clear, and we have to think about what could be done. Oh.
Do you have video there?
There is, yeah. At least there was. Right. But now maybe I get this way. I mean, we have to think about exploration strategy. There has to be more exploration. Playing simply the better arm, yet the arm that you consider better at the moment, is not a good idea. You have to do some exploration. There are an infinity of exploration strategy. But there is one that is very famous, and that is a strategy that is in the literature called epsilon greedy strategy. You play predominantly with a certain probability the arm you consider better, but with a certain epsilon to play the other arm to explore. But epsilon is used for my bounds of confidence, and I do not want to change that. And what in the literature is called epsilon greedy strategy, I call that now gamma greedy strategy, to stick to my old terminology. Okay, if we do that and introduce now gamma greedy exploration, we get the following. That is what you have seen in the animation, lonely Canadians. That were the ones with social exchange, but in both cases in the upper row, they play what they consider the better arm. If we now use gamma greedy exploration, and they play the better, what they consider better, with 85% probability, 15% exploration, then we get for lonely Canapians this, for social Canapians that. They here obviously get very close as one major cluster, a bit littered the display by the trajectories, but they get as a cluster very close already here, that is a period 100, to the truth. Okay, if we have that, it is clear we need some measurement for success to compare. What can we do? Well, again, alternatives. The first thing is, let's simply measure the Euclidean distance to the truth. Okay, that would be the maximum of that would depend upon the position of t, but that is a minor point. We could also think in what they gamble away. We, as the modelers, little gods, we know the objective probability. So we could imagine the situation, what you have to expect in terms of payoff success, given you always play the better arm. We know what that is. So we can look and compare their losses, what they gamble away, compared to what they could get playing all the time, consistently, the better arm. And that would be another and very telling measurement of success. We could simply count and compute the percentage that are in the right half, so to speak, where the truth is above or below the diode. Or we can look at the percentage of agents that actually play the better arm. All that are possibilities. We will use all. And now I want a first completion of my scenario. Everything is as you have seen it before, but we add an additional class of agents, free riders, epistemic free riders. They have the finger in the wind. They do not do any statistics. They simply look around and do nothing but social learning. They use this epsilon Euclidean distance to find out who the epsilon is. And then they play what they consider actually the better art. That is my complete, in the first step at least, complete scenario. Now I want to compare. And now the right part of this graphics comes into play, in which I take lonely Canapians as my benchmark. How do they perform? And with that, I want to compare how social, how with free riders perform. So that is what you see here is based upon 50 runs of lonely Canapians. That is not a linear time scale, it is exponential. And logarithmic it is. And here in the upper one, we have the Euclidean distance with the two. And what you see here is accumulated losses versus cumulated best response. And the dark black line is always the mean. The gray lines indicate one standard deviation. To get a feeling, simply to get a feeling what is going on. Now, you have understood the graphics, and now let's see what is there. The red ones are our free riders. Here you see evolving the statistics. Here in the center, the truth distance. Here in the center, the losses versus best response. And we see the results after 500 periods. We have epsilon, that is 0.1, alpha 0.2, and we explore gamma greedy strategy, 85% probability for playing what you consider the better arm. Okay, if we look at that, we see certain, that buff is what we have seen as an animation before, but let's focus on truth distance first. So look at what is going on as to the free riders. Truth distance, the free riders are the red ones, and we see they perform much worse than both social Canapians blue and the benchmark lonely Canapians in black. That is obvious and probably no surprise. But let's look at that second point. As to the truth distance, beginning until about period 40, the social Canapians, the blue ones here, perform worse than benchmark lonely Canapians. But later, the social Canapians perform significantly better than their lonely counterparts. That is interesting. How comes? We have to explain that. And we can explain it. This is period 9 of the process that you have seen. That is the last period, period 500. And what we see is that the free riders get to the true value only under the leadership of truth seekers. But given epsilon and alpha constellations, as a free rider, you may get lost. And the ones, no connection to any truth seeker any longer. And that is the case for all free riders that are marked with the yellow circle. They are lost, and they are lost forever. They are lost already in period 9, and they keep that status until the very end, with the result that you have seen. Namely, they perform much less good. There was the second problem. Why are the lonely Canapians worse? Why do they perform worse than the social Canapian? If we look, that is what you have seen as a movie. Now I simply removed the trajectories to get the positions clearer. Initially, the social exchange slows down the Canapians. That is true. But within clusters of mutual influence, then later, social exchange dampens the effects of very strange sequences of experiments as to the results. And that has consequences that Canapians gather closer around the truth than their lonely counterparts. That is the explanation to that. And you can see that here we have the lonely Canapians in the upper row, period 10, 50, and at the very end. And here the social Canapians. The social Canapians are a bit hidden, and therefore I magnify this area a bit by that. Okay, that we have seen, and now a second experiment. We keep everything constant, but the bounds of confidence bigger. Let's run that. What do we see? Well, that looks good. Nothing, nobody is left behind. So free riders. Nobody is left behind. And you see how they develop over time. You see how they develop over time. The only difference to the experiment before is bounds of confidence. That is bigger now, significantly bigger. But if we look into the details of that, we see something strange. And that is, we now look at what is gambled away. What is gambled away? So losses versus consistently best response. Let's look at the dark red line, dark blue. That are the mean values for the truth seekers and the free riders. And what do we see? At about here it starts. And the free riders gamble away much less than the truth seekers. That is to be explained. And the explanation is easy. The free riders do not do experimentation. They always play what they consider the better arm. And our truth seekers continue experimenting. And that is the reason. And we realize, obviously, there can be too much exploration. And our truth seekers gambled away possible successes by too much exploration. Okay, that were illustrations. I come to my final part. What are the perspectives? Here, with regard to that, I do not have in mind, at least not primarily so, description of actual processes. I'm thinking about policies, about epistemic policies. What should one do? What are efficient epistemic policies? So I look at the parameters here more under the perspective that are values that can be changed by individual or collective choice. No? Maybe under a moderator or a philosophy of science person that thinks, and engineering-like thinking, what are efficient policies in such a context? No? And then we might think about truth approximation and costs to get to the truth. No? Under the perspective, what are the effects of relying more or less on present experience, including more or less distant views into my learning, following this or that exploration strategy with data, for example, this or that gamma greediness, having more or less truth seekers in the community, or I didn't speak about that, under this or that exchange regime. For instance, I could assume my truth seekers are able to identify the free riders and do not consider them in terms of updating. That has consequences. So here it was true. So far, truth seekers interact with all, but we could analyze a situation in which truth seekers having a detection capability interact only with truth seekers. And based upon that, we could design efficient epistemic policies. And that is the perspective that I have. It is more epistemic engineering, not description in the first place. But what I have done, I admit, that are illustrations, just illustrations, but we want to get a complete overview. How to do that? Well, I think one can do something. Have in mind, that is our space. First of all, it should not matter whether the position of the truth is always above or below the diagonal. Therefore, let's focus on just one side. And there we position the scenario approach, the truth. Then we analyze. Then have in mind, here in that top left corner, that is a situation in which one arm has a high and the other one a low probability. Here in that corner, both arms very similar and both low. Here, very similar, but both high. That should cover the possibilities for the truth. Then it is clear this sound contact zone along the diagonal, depending upon the size of epsilon, that is something important, because only there is exchange between agents that at least predominantly play different parts. That we can exploit. So mirror symmetries, scenario approach with regard to capital T. Then it might help that we experiment not with thousands of random start distributions. What we do instead, we idealize deterministically a certain type of random start distribution. And we do our experiments all the time with that. That is an approach that Ulrich Krause and me used already for radicalization processes in a two-dimensional space where we always used the same status distribution, but under order statistics point of view, it was a very representative star distribution, one all the time. Then I think that is based upon experience. I think medium-sized populations between 50 or 100, at least for the start, that is sufficient to get to what is working here. My last point is, and that is something I'm really working hard on at the moment, is advanced visualizations. Think of the following. I could simultaneously have a k times k grid array of two-dimensional displays of animated, colored, three-dimensional graphics that is possible to realize. That allows a display of 7 dimensions. And that is a lot. And that is doable. It is beyond anything printable, that is clear, but it is doable. That is a technical remark. Now a more philosophical remark. And that is this approach that implements the view from above. The simulator that we are using, or I was using, is a creation machine for artificial worlds. And in that world, and with regard to that world, we are little gods. Observing from above, we measure what agents, our creatures down there, can't measure. Their distance to the truth, the successes that they gamble away, and so on. All that is possible using in social epistemology or in epistemology and simulator like that. And now, and that are my last remarks, let's extend my basic scenario under the pressure of actual developments a bit more. No, that is, I wanted to skip that. And I want to hint to, of course, all what I have said here is dual use technology. And there are even, so to speak, inverted interpretations. That we have seen this type of dynamics. But let's ask, who are the blues? Who are the reds? And let's recall what happened in 2016 in the Cambridge Analytica affair, in Brexit or in the Trump campaign. And involved was someone, whom you know, at that time, Steve Bannon was vice president of Cambridge Analytica. We could look at everything what I have done so far in the following way. There is a conspiracy of agents that agree to manipulate an ongoing opinion stream. They want to steer the opinion stream direction, capital T, which is now Trump. They start with opinions that are messages sent to others, that they spread over the whole opinion space, but with a speed that is controlled by some statistical parameters. They move direction, capital T. And we see it would work given my mechanism. So there are inverted interpretation, and dual use is completely clear. And we can explicitly, on top of truth seeking, with the truth signal from the truth, now additionally introduce a disinformation signal. Steve Bannon, that is a famous the media destroy, so to speak, their effects. Okay. We could add that to our scenario that, by the way, are now visualizations and computations based on Julia, no longer on NetLogo. We have the truth, but in this brownie area there, that is, so to speak, the center of shit. And the assumption is that whoever has that signal, the disinformation signal, within her confidence area is influenced by that. And we have an additional parameter about the strength of that signals, and it then counts in certain multiples of normal agents and affects agents. It is heard, this signal, by agents that have it in their neighborhood. That is the next.
That's the video.
Oh yeah, now I have it. So now you see what is going on. Here we have our truth seekers, and we have the free riders. It is a scenario in which the free riders and the truth seekers, they exchange with all others, and the disinformation signal affects all. It affects all. And you can see how the truth try to escape, so to speak, direction truth, but can't. And in between the truth seekers and we have the free riders. Nobody is exactly on the position of the disinformation signal, but they are kept in that area. This initial distribution started with a light majority in the better half, but that is no longer the case at the very end. In public voting on the two policies, now I interpret that as policies, the former majority for the better half is gone, and by a disinformation signal positioned here, you would be able, so to speak, in my model world, to destroy the majority that you had before without. That you can study. Of course, it depends upon the position of the disinformation signal, and immediately it is clear you can start to think about dual use, how to manipulate a whole community. Wait, is it? So, without disinformation, we would have that for the same star distribution. I always use the same here. Everybody would end up at the truth. It would be to the left without. It would be 100% majority for the right, for the better half. But that is gone under the disinformation. Of course, we have to study different scenarios. That is what we have seen without disinformation. Then we have seen, secondly, truth seekers interact with all, free riders interact with all, disinformation affects all, but we could change that. Here you see same star distribution, but we consider truth seekers, they are immune against the disinformation signal. They are immune under the conditions that I have it would not help. Still, the majority for the worse are no longer the majority for the better are. What would help that you see here is that truth seekers have a capability of type detection. They are not immune against disinformation. They avoid exchange with free riders as well. That would help. That would help. Okay. There is a certain type of research. In the US, it becomes difficult to do that. On April 18, National Science Foundation, in an information, they said that because of presidential action, proposals that regard mis, dis, and malinformation that could be used to infringe on the constitutional protected speech rights of American citizens across the United States, that will no longer get prioritized funding. Okay, that is the US, and I stop with the let's do in Europe. That's my talk.
So thank you, Rainer. Quite intense. And we can open discussion. We don't have much time because we have to close at 4:30. So maybe one question, one input, one feedback from the two discussants. Federico, please. Yep.
Can I start?
Yeah, this discussion are different in terms of, so there's a diverse set of discussions. So
No color of jacket. But...
that kind of jacket, yes.
Right. Thanks a lot. Let me just start by saying that it's an honor and a privilege to to discuss your work, especially such such a rich presentation. I'm very happy about this. Thank you for being here and accepting our invitation. It was lovely to, even if in general, even if one is not very much acquainted with the kind of research you have presented, especially the substantial paper of opinion dynamics. I think one of the greatest things to see is how this kind of modeling, this kind of simulation sheds light on the heterogeneity of dynamics that can bring about one observable social phenomenon. Sometimes we observe social phenomena and we think that the causal mechanisms that underlie it is quite clear, but actually you showed us an example of how chaotic dynamics can be responsible for different trajectories for the same outcome. I always find this to be very fascinating. Earlier over lunch, you shared a nice story about an old pupil of yours who made you such a difficult question that you needed to take some time off to find a solution. I'm afraid I'm not going to ask any such questions, but still, three elements I would like to. I'm curious to hear your feedback about. So. Premise is it's not very easy because this was very rich, and so I hope I haven't missed any important elements, but I was, to my understanding, this the dynamics between Carnapians and free riders highly depends on the proportion of lonely Carnapians, right? And which affects how social Carnapians then approach the truth, and all the more the way the free riders, the epistemic free riders, make up their minds. I was wondering, to what extent do you think that something close in reality to lonely Carnapians exist? So what could we think of? You know, of course, it's an ideal type, of course. But I was wondering, what did you have in mind as possible, you know, realizations which are close enough to the ideal type of lonely Carnapians, or maybe which aspects of our social lives, because we might, you know, switch kinds of rationality depending on the context. Are there any, you know, contexts in social life where we might act more like lonely Carnapians with respect to other, where we might be more like epistemic free riders and stuff? And because I was wondering, you know, the Carnapian or Bayesian or whatever, I mean, updating one's beliefs means, you know, collecting data from the world, right? And you can't really escape social exchange while, you know, you conduct your life and collect data from the world and then update your beliefs. So I was wondering to what that. I've got a couple of more, but you asked us one question each. So, but otherwise,
I will play a light role of discussion, just one question or one comment. Do we prefer to respond?
I think, yeah. I mean, in my framework, the lonely Carnapians, they are used for benchmark, not simply for benchmark. I could imagine that lonely Carnapians that works, and they are then fairly good if you can run lonely, lots and lots of experiments with high speed, then of course. But if we speak about content with medical treatment, and we do not have that much experiments, and it is hard to run them, and then social exchange becomes much more important. But in my role, or in my scenarios, okay, I can run lonely Carnapians, but the whole framework is made basically for exchange. This way or that way, different compositions of the populations in terms of truth seekers and the number of free riders, and taking the Carnapians, the lonely Carnapians, only as a benchmark. There are cases now. I never asked myself your question, by the way, but it is a good question. And then I would say, there may be some situations in which, as a lonely Carnapians, if I simply have to find out the bias of a coin, probably I could do that fairly good at my own if I have an hour of time. But with a serious medical treatment, that is completely different.
Right. Okay. Thank you, Cristiano. Like to comment?
Well, very shortly. Thank you very much. It was a very fascinating speech, and I wish I could have listened to it like any other of you without having to think about what question can I make. No, because what I'm about to say is the lessons learned. Do not accept to be a discussant if you don't read the paper, because this was on the spot, very, very dense, very complex, and so it's like a disclaimer because of my very humble question. No, rather than a question, I have a comment. Maybe it's because I missed some part. In a way, we were compelled to follow your scenario and the way it's strong effect. But then I was wondering internally, saying, but why this happened? And I think, I may be wrong, is that maybe it's implicit in the model, but I could not find at the beginning and follow what is the logic behind the social exchange. Why is epsilon small? Why epsilon increase or decrease? How do the agents influence each other? And, you know, for instance, how the agent process the information that leads them to decipher one bet or the other. And it's probably in a theoretical model added in some implicit hypothesis. Maybe my question is too empirical, but that's what I I missed. Okay.
I understand that question, and first of all, I apologize for I had no paper.
Okay.
And it's not yet written, but it will be written. Okay, now as to the epsilon. I took the epsilon as given. There is a certain range of possible values, and I always tried to understand the effects of epsilon by simply finding out. Was happy to have an algorithm that selects and finds all the epsilons that only matter. But I mean, the model, the bounded confidence model, is in a certain sense completely macroscopic. It does not go into the details. It makes an opinion to a numerical real valued value in a certain range of numbers. But in reality, we exchange arguments. Arguments are not modeled here. It is reduced to a certain point. And arguments, and I never assume that people are actually doing this type of calculations that in my dynamical system delivers the next period's opinions. It is considered, I consider that as a summary description of much more detailed mechanisms and processes that are working on lower levels that I can't really explain. I'm sure that they exist. I want to cover that all by a very macroscopic approach in a certain sense.
And consequential approach.
By this equation approach. But let me say, in my intellectual youth, and that was, I would say, 50 years ago, I tried it on the other side of the extreme. I have written an habilitation, Formal Dialectics, and that was trying to use methods, basically formal logic, to directly model dialogues in which arguments are exchanged based on a certain knowledge base, with a certain structures, questions could be asked. And by that, I wanted to find the pattern of rational exchange. I got habilitations for that damn project, but I got to the limits of my intelligence, what is really a painful experience. And where one had to go kilometers, I managed, let's say, millimeters. And that was it. But why? My decisive failure was the level of resolution was too low. I got into the details and involved into the details. And that was an ocean. I couldn't manage that. And then maybe somehow I switched the frontiers and started from the other side, maybe by far, abstracting away by far too much. I think both is compatible, and no level. It is a pragmatic choice where to start, and then you have to try and look where you get. But you are completely right in stressing. You abstract away lots and lots of important points which exist, what I accept immediately, but that I can't cover, at least not at the moment, and probably not in my life.
Thank you, Cristiano. Any other question or comments? Francesco? Yeah.
Yeah, I think I have two questions, but I'll ask just one, and then if I have time, I'll ask the other one later. It's really a clarificatory question, because I didn't get the very last of your slides, the one with the 4 graphs. if you can go back there, I didn't get the logic. Yeah, that one. I didn't get the logic behind the fourth. Behind that one. So what is the mechanism that generates that pattern?
That is basically the same in terms of truth seeking, how you do that, exchange, but it is assumed truth seekers are able to detect truth seekers and to distinguish them from free riders. Truth seekers will only exchange with truth seekers. Free riders do not count. The free riders exchange with themselves and the truth seekers.
Right.
They have them and therefore they function as leaders. Additionally, the disinfo affects only the free riders. So the truth seekers are assumed to be able to detect what is simply a disinformation signal. This is
So I guess what I don't get is how comes that the free riders end up converging, end up following the truth seekers, and there isn't some kind of process that carries them away at some point.
That is because of the boundaries. They take seriously the truth seekers that are within their confidence area, and they lead them direction truth, or a major part of that direction truth. Some may be left somewhere, or I can't read exactly the results here, but the mechanism is leadership by truth seekers, and they have the connection to them because they take them seriously, while they themselves are not taken seriously by the truth seekers. And therefore this effect that only the free riders are affected by the disinformation signal. But if then the truth seekers accept a serious person, the free riders, indirectly they are influenced by the disinformation signal, and they may get captured, really captured, far distance from the truth, and can't get away because they are under the influence of people that are under the influence of the. That is, yeah, the mechanism.
Okay, second take in case we have time. Who's next?
Very simple question. So
Simple, sure.
Yeah.
I know you, man.
So there are only truth seekers and free riders, and truth seekers are blue and free riders red. No other.
No,
And what's represented by size? Like how many truth seekers or free riders are on the spot?
here it is with 50 truth seekers. Let me look at them. No, I think it is 50 to 20. 50, yeah.
Yeah, thank you.
But that matters. No? That is an important point. No.
Thank you. Thomas.
Thank you for the talk, and thank you, Flaminio, for spreading the voice that Rainier was in town. And sorry, we have to leave in a few minutes, so we'll not sit through the rest of the discussion. But what I wanted to ask is, so I was thinking of how to make bridges between the two parts of your presentation. And one of those ways to build a bridge is to think what happens if we increase epsilon as small increments in the second model. Do you also observe another model?
I mean, that epsilon is a decisive value here. No? And we have to think about high-dimensional parameter space, how to get an overview. I mean, that is something that is sleep-taking. No? You have to think about it. I describe this 7 dimensions, which I think I can manage in one visualization. But it has to be done, and it has to be developed. I did some first steps into that direction, and there's more possible than one can think. There is somehow no incentive to do that, because except for Jas, nobody could be able to publish that because it is no longer printable, but in just animations can be included, and therefore that would be the natural journal for that.
So I appreciate the parsimony, but the reason I was asking about the effect of epsilon on the second model is that there is also another key difference between the two models, is the starting position of the agents, which are at fixed intervals on the opinion dimension in the first model, and here you start out randomly. And the point might be made that perhaps if you start out randomly in the first model, we don't see that non-monotonic effect of epsilon. Could that be?
No. These non-monotonic effects that I described, you find that firstly in the two-dimensional case as well, and it is completely independent of whether I start with equally spaced opinions or not. So I very much appreciate your question to have the occasion to clarify that. Do not think that the non-monotonicities are due to equally spaced start profiles. That is independent.
Jessica?
Yeah, I also a couple of questions, but I will start with one. Well, this is a very interesting model. I was wondering what would happen if you add that agents can imitate each other, can switch between truth seekers or free riders based on their
Some evolutionary age.
Yeah, I mean, we could try to blur the distinction, with a certain probability you are this, and with a counter probability you are the other type. So it is not time consistent, your time. So it can change. Yeah, I do not know. Is my answer.
Yeah, it was something more rather than an exogenous switch that if I'm a free rider and I look around, I don't know, my round of context, and I see that truth seekers are relatively doing better, I become a truth seeker or the other.
I mean, that is the direction about how to reduce exploration. You may get a feeling for success rates of others whose type you can identify. That would be a way to use social learning, special type, to control what you do in terms of exploration and to reduce, for instance, the gamma in the gamma greedy strategy. Yeah, that could be done.
Good point. I will add, if I may, a short question myself. Then we start with another one. So this kind of free writing idea, I found a little bit, how to say, out of the context in sense that at the end of the day, there's a problem of sampling other opinions, right? And there's exploitation, and the bounded context also deciding how much I can sample. And sampling is a costly process, which also had to do with this kind of exploitation kind of dynamics. And free writers could be free writing in such a way that they reduce the sampling of other opinion and they follow maybe some, and they don't pay the cost of the sampling of other opinion, which is a costly process. What about adding this friction about the cost of sampling other opinion? Because at the end of the day, even enlarging the bounded context, it means that you don't have a cost, but you're sampling other opinion larger, right? And this is, in my opinion, in terms of exploitation, is a problem of cost distribution. And this also explains why, for instance, in social system, we have structured in such a way that the truth seeker, which has to bear the cost of exploitation of the truth, are like these scientific people. They are a concentration of cost of people with a costly and high-risking activity in terms of truth exploration. And it's good that there are free riders like the public who bear the cost of the truth-seeking process, and they can probably enjoy the benefits. So this free rider thing without a structure of cost of exploration in the space of opinion, I did not get really this free rider, why these people are free riding, poor guys, right? So what about adding cost of exploration?
One could do that, but it is another parameter. And I have already a lot of them. Once I have understood what I have already, I would be prepared to make this calculation costly explicitly and to study the effects. No. You are right, yeah, but it is already complex sufficiently much.
Yeah, well, you know, also the example of Trump-Brown discussion about that. It's a discussion about if it's collectively efficient to structure the system of exploration of knowledge in our society in such a way that academics are paid to do this kind of truth exploration every day, and the others are just you know, buying the scientific output like
it is probably a good idea to have comparatively low division of labor, and some are of the profession, in the profession that does, you know, the experiments and tries and calculates. For the most part, people are not. That could be done, yeah. But that is the only way how
you get this kind of stuff.
yeah.
Anyway, that's it.
One quick and very simple question. Like, I was just wondering if you have done a model with the free rider learning from free rider only, like the variation of the last one. So the truth seeker, you know, learning from truth seeker, free riders, running only from free riders.
Yeah, that would be a complete disaster. So, yeah. But you are right, that should be done. If someone could convince the free riders not to listen to the damned intellectuals, then it is for sure that they will end up at the disinformation thing.
Yeah, I was trying to relate the idea with the, you know, antis, you know, establishment sentiments. So yeah.
You mentioned earlier that the boundary confidence model is like a macro simplification of how social epistemology actually works. I was wondering, are there other alternative macro simplifications, and why did you come across decide upon this macro simplification rather than maybe some alternatives?
Yeah, there is a multiplicity of such simplifications. The de Groot model that I mentioned at the beginning, or this the second one that I mentioned, Friedkin Johnson is another one, and there are much more. They are all in the same spirit. I recall very much and very good the discussions with Prof. I mean, really this de Groot model, of course. But de Groot was a model in which you assign drawings. They sum up to one, and you do weighted arguments. But to assign weights requires, you know, if you assign them in any reasonable, based on something, weight requires information about the persons to which you assign the weights. We, Bowser and me, long distance running in the Bremen Bürger Park, we had in mind another situation, and that was the situation of Delphi studies. What could agents do given a Delphi study format of exchange? Do you know the Delphi study? That is invented by the Rand Corporation already, I think, late 40s or early 50s. You have a group of experts, you want to extract some common opinion, at best a consensus of experts, and you do that by they formulate their opinions in an anonymized way. The opinions are spread and handed over to the other experts. Then in a second round, they revise, and so on and so on. Not a major number of steps, maybe 5, 10 or so. And then you get a final conclusion. If you do that, you do not have information about the agents other experts except for their opinions. And what to do then if you are asking and analyzing chances for consensus? And in that situation, not being able to assign weights in the way de Groot and others that made it more precise did that, we thought, well, simply taking the distance. The serious ones are those not too far away. That might be an approach. Then we did that. But that was the application in mind, that the structure that you get by that is a structure that you could use to describe social platform exchange as we know it about digital platforms today. That was not even at the horizon when we started with the discussions about that. Today, I would immediately come up with that is a structure of communication as we find that on digital media of a certain sort. That is behind.
Thank you. Thank you. Martin?
Yes, thank you for the presentation. My question is about the first model, the bounded confidence, and I apologize if you have already published or it's already answered in any publications. But so in your example, we looked at the uniform distribution of opinions that are evenly spaced from each other. But I was wondering if you've looked into more discrete opinions, not continuous, and into different distributions of agents among these discrete opinions, and if they cluster in certain opinions, how does this dynamic?
It has an extreme effect. Start distribution. First of all, the start distribution really matters. If I start already with the B-model distribution that has consequences, and it depends, then let's look where the peaks are. All that has consequences. But you can study that in the same way as it is studied here. Look for what is going on in terms of clusters. And that I consider important. This approach, idealized deterministically a start distribution, and then look for the effects. Avoid statistical analysis. You can go into the single runs and understand the mechanism that is going on. That can be applied to any type of start distribution. And I have that all. If it is difficult to mathematically calculate explicitly a certain start distribution, use Julia, run 1 billion of start distribution of that type, calculate the expected value in that profile, take that as your start profile and analyze the mechanism. It is quite easy, can be done. I have the problems for that, and I would recommend to do that for beta distribution, because with 2 parameters, you can basically produce and generate any type of shape that you want, at least for the start, and then you can do that. The approach works.
Thank you.
Okay, there's another meeting in 10 minutes, so I would suggest that in case you want to go on discussing with Rainer, we can move to the bar, having a coffee, and go on discussing for those of you who would like to, talk a little bit. And for the moment, I'd like to thank Rainer for this intense, brilliant talk. I'd like to thank Cristiano and Federico for discussing, and everybody for feedback and comments. I'd like to also thank those connected on Zoom. And yeah, it has been intense, and thank you very much, and see you next time, right? And I hope you like the discussion, and but
I like
we go on discussing also dinner, right? Thank you very much.